Hello, welcome to topic 1.5. We are going to finish up the financial math. We're going to talk about some inflation, some depreciation, and some other just financial things. Do some example problems, and here we go. So, the general inflation is the general increase in the price of goods and services over time. You know that word. It reduces your purchasing power. You might see that word. To find out how much something is worth, taking inflation into account, we find the index of the value. So if something is worth $500 today, what's it going to be worth in 2030? That's called the index value. The index value, another way of putting the index value, we use this is the future value, like in our calculators. And this is just simple inflation, just adding a certain percentage every year. You take your present value times the inflation rate raised to the number of years. So we'll do some examples of that in just a second. To understand how well an investment will perform, we can consider its final value in terms of today's purchasing power. So it's like the real value should be like the present value is another way of putting that. The present value is equal to the future value divided by the inflation rate. So these are kind of like the opposite of each other. Here you multiply and here you divide. We'll do some examples. Don't forget that when you're using like an equation like this, when you're not working in the TVM solver, an inflation rate, so if they say it inflates, if they say it's an inflation rate of 3%, if you take 3% of something, that's actually going down. To make it an inflation rate where you're increasing 3%, you need to multiply by 1.03, which means you take 100% of the previous year and then you add another 3%, and then 100% of the next, and add another 3%, and then 100% plus 3%. So a 3% inflation rate is a rate of 1.03 in equations. Why? I just explained that. All right, example 1. So if inflation is roughly 3% per year, we'll do A and B under that, 3% per year. A candy bar today costs $1. How much will the candy bar cost in 23 years? So today you ask, hey mom, can I have $1 for a candy bar? How much will your children be asking you to buy a candy bar? So you could do 1 times, that's the present value, times the inflation rate, 1.03 times 23. And that would give you, that's an easy calculation. It's about 1.974, so forth and so on. So about $2. So your children will need $2 for a candy bar. And my grandchildren will need, no, not grandchildren yet. Or you could do this in your calculator actually. You could do a scenario with the TVM solver where N is the number of years, so that'd be 23. Since we're not compounding, there's technically 23 compounds. This is just a simple scenario. Inflation is happening every year. So payments are 1 per year, compounds are 1 per year. Interest rate is 3%. When you're using your TVM solver, this will increase 3%. The present value is $1. Payment is nothing. We're going to turn $1 into, hopefully it's the same number as that. So we're going to plug that in our calculator. And let's work this out here. We've got 23 years at 3%. $1 turns into 1.9754. See? It's the same thing. So you can run the same thing using the TVM solver. Okay, to retire today I need 1.5 million. That's my magic number. If somehow I end up with 1.5 million tomorrow, I'm out of here. And then I'll come back and work pro bono. Who knows? Probably not. Alright, what do I need to retire in 25 years? So again, simple sort of situation. We could do it in our calculator where we got 25 years. Interest rate is 3%. So 1.5 million in today's dollars. How much is that in 25 years from now dollars? Present value is 1.5 million. Payment 0. Future value, that's what we're trying to figure out. And then we'll keep that as 1. So I'm just gonna do this in my calculator. I almost prefer to do it in my calculator in the TVM solver just because I like it. Makes me feel smart. So anyway, turns into that. So actually, I need to aim for a retirement of about I'm never going to retire. 3.1 million. Oh man. Let's just run that real quick. 150 million, or 1.5 million, I mean, times 1.03 to the 25th power. Yep. 3,140,000. We're around to 3 sig figs. Oh man. 1.5 doesn't sound so bad actually. But that sounds unattainable. Oh man. Alright, example 2. My grandpa was complaining about the price of gas. He says in 1960 gas was 30 cents a gallon. Today gas is $2.50 per gallon. What has been the average rate of inflation since 1960? Alright, so here's how we can plug this into our calculator. How many years has it been since 1960? This is just an inflation question. This is not a compounding thing. We're just going to keep these as 1. That means every year it adds 3% or whatever the percentage is. Interest rate is what we're trying to figure out. Present value, think of that as 0.30. Payment 0. The future value is negative 2.5. One of these has to be positive, one of them has to be negative for this to work. And then that's just how it goes. Typically is what we have to do. So you could make this negative, but then you'd have to make this positive. The n, so number of years, it's 2019 minus 1960.
Mackenzie, please come to the main office.
It's 59 years of inflation. So let's plug that in and see what we end up with. 59 years of inflation. 30 cents turns into $2.50. And we can figure out the inflation rate like that. So 3.66%. That's about right. And this is real. 3.66%. It's about 3.66. Okay, pretty good. It's normal. Example 3. Gemma invested $4,000 in an account for 5 years. Compounded half yearly, interesting. 3% interest rate. Let's calculate the value of the investment after 5 years. So after 5 years, we've got 5 years compounded half yearly. So that's twice a year. So how many total compounds? That would be 10. 5 times 2. Interest rate for this investment was 4.8. The present value was, I'm going to call this $4,000 into the bank. So I'm going to make that negative. She was not making payments on it. She just put it in the bank and forgot about it. It's half yearly. So there are 2 compounds per year, and we always want to make these the same. The money you're getting, the interest is paying you twice a year as well. So that's how that's kind of working. The future value is what we're looking for, so let's go plug that in. That was 10, 4.8, negative 4,000, and that was twice a year. Future value. So your 4,000 turns into 5,060. So 5,070 and 60 cents. Okay, this is the next question. It says find the real value of the investment. So here's where you go back up here. The real value is, this is how we define this. Future value divided by inflation rate raised to the number of years. So all you do is you take your future value, and this time we're going to divide it by 1 point. The inflation was 3%, and it was for 5 years. So we're going to plug that into our calculator and call that good. 5,070.60 divided by 1.03 to the fifth. 4373.94. All right, so you might think of it like, oh man, that's a lot of money, but really, in today's money, it's really only this much money. All right, so that is a lot more, but when you think about inflation, really you're going from $4,000 to an equivalent of today's money of $4,373. Not as good looking, I guess, when you think about inflation. Silly inflation. Never going to retire. Depreciation, the loss of a value of an investment over time. Example 4. When purchased, my new car was $26,000. After 10 years of ownership, I sold it for $4,000. That's what happens. What was the average rate of depreciation for the car? Alright, so here's what we're going to do. We had 10 years, and this isn't compounding, this is just at the end of every year, it's going to depreciate a certain percentage. Alright, so we're going to keep this as 1 and 1. This is a simple situation. This is 10 years of ownership. What was the average rate? That's what I'm looking for, the interest rate. The present value, think of it like this. You put $26,000 into your car, and you got out $4,000. You put $26,000 into it, and you got out $4,000. So you're putting money into the car. That's why I made it negative. You're getting $4,000 back from the car. We're not making payments on it. This is strictly depreciation. We're just trying to get that interest rate. So let's go and figure that out. There it is. Alright, so this was 10 years of owning the car. Interest rate is unknown. We started with $26,000 payment, and we ended up with $44,000. This was 1 time per year, and that automatically puts those as the same. I'm not even sure why they even have 2 of those. But here we go. Interest rate is negative 17%, roughly. So it's depreciating by 17% every year. You're losing 17% of the value of the car every year. 17% roughly. And lastly, example 5 on this page, and then we'll go to a new video. Example 5, if a yacht depreciates at roughly 20%, how long until a $100,000 yacht depreciated to $3,000? Which is when I would be able to afford it. So we're starting, N is the question here. This is what we're questioning. And the interest rate is 20%, but we're depreciating, so we're going to put that as negative 20%. Present value is, let's think of it as negative 100,000. Again, we're kind of playing the negative positive game here. The future value is $3,000, so we can kind of just run that simple, no compounds. sort of situation. So let's see here, we're going to plug in negative 20. Present value is 100,000, and this needs to become 3,000 until I can afford it. So how long is it going to take? 15, about 16 years. About 16 years. 15.7. I'm going to plan on 16 years. So 16 years I can get that yacht. I should go shopping now, and then I'll find a nice yacht. Alright, so we covered inflation. We covered the real value, which is just a quick little computation here. We covered depreciation. Now the rest of this is practice problems. So what we're going to do in class, let's see, we got 1, 2, 3, 4, 5, 6, 7, 8, 9. Next video I'll go over some of these, and then the rest will be your homework. All right.